As night settles and the day loosens its hold, you arrive at a small, quiet pause, where the breath begins to move more slowly, and the room grows gentle by degrees. In this hush, tension seems to unknot on its own, the jaw softening, the shoulders finding an easier shape, thoughts drifting toward the edge of sleep like leaves following a slow current. Within that softness, we can wonder about a question that glows at the edge of science. Is time travel possible in our universe? We will follow a single, unhurried thread, moving from the steady rhythm of everyday clocks to the pliable fabric of space-time, where swift motion can stretch a moment, gravity can tilt the order of events, and carefully imagined doorways such as wormholes and closed loops of light are held as working ideas rather than promises. There is nothing to chase here, only room to listen and to rest inside the question. If this quiet wandering brings you ease, a light tap on like and subscribe helps other sleepy listeners find this harbor. For now, stay with the slow rhythm already here and drift as the story begins. Time is the one presence you never quite hold in your hand, yet it rests on everything you do, like a soft weight you barely notice until you look for it. You live inside it, count your days by it, mark your hopes and memories with it. But the counting is not the thing itself, just as a thermometer is not warmth. What you hear as seconds is only the sound of a tool, not the river it skims. The river is stranger than the stories we learned as children, and more powerful than the habits we use to tame it. And as the room grows quiet, we can ease the curtain back, a finger's width at a time, to see more clearly. The beginning of the path is simple and deep at once, a question that has waited in plain sight. What is time, really? Is it a flow carrying us, a direction that leans forward, or something quieter that does not move at all but holds movement within it? Following that question, the path gently lengthens into another. How a person might arrive in the future faster than their neighbors, not as a daydream, but as a real effect we already understand. The method exists. The difficulty is in the scales we would need and the speeds that are hard to reach. Beyond that calm, practical doorway, a deeper hallway bends toward the past, and the puzzle of whether a moment already lived can be visited again. Some minds look for tunnels through the fabric, the kind we call wormholes, while others raise careful warnings about loops that knot logic and turn cause and effect against themselves. Far along this same path lies a place where edges fray, where our rules begin to wobble and the familiar scaffolding of reality feels thin. And near that edge, we can sketch the outline of a machine meant to ride the contours of time, not as a toy for wishes, but as a clear picture of how such a thing might work. Take a slow glance at the nearest clock. By the time our wandering settles, its voice may sound a little different to you. For most of your life, time feels like air. You breathe it without thinking. It shapes your mornings, measures your aging in the mirror, and makes the changes outside your window look orderly. The mind treats it as a steady river that moves in one direction, with you carried along in the current. You name the banks with words like yesterday and tomorrow, and call the midpoint now. And it is enough, most days, to stay afloat and steer a little. Yet, in the same way that still water can hide a deep tide, the simple picture invites a slower look. Is time only a way to sort memories and plans, a tidy calendar stretched over the days? Or is it woven into the very fabric of the world so tightly that to speak about anything at all is to speak about it? At first glance, the answer seems obvious. Time is what the clock measures, what the calendar tracks. You wake when the sky brightens. You fill the hours with errands or work or quiet joys, and you return to the pillow at night because the hands have turned. You check your watch and read 3:15 inches the afternoon. You promise to meet a friend next Tuesday, and it works, as long as everyone trusts the same rhythm. In this everyday sense, time is the frame that keeps the day from unraveling. Yet, the closer science has looked, the more the frame has softened. The picture that first appears rigid becomes pliant under careful light. Time is not an invisible metronome ticking far away, separate and untouchable. It is braided with space itself so closely that they cannot be pulled apart without losing what they are. The world is not built on two separate axes, here and now, but on one continuous fabric that holds both. It helps to imagine that fabric not as something you can touch, but as a calm, silent sheet stretched wide enough to cradle every star, every planet, every beam of light, and the dark distances between. This sheet is what we call spacetime, a single structure that does not sort space and time into different bins, but keeps them together as different faces of the same thing. The names we use for direction and distance, and the names we use for before and after, are threads in one cloth. If you have always thought of space as where and time as when, it can be soothing to think of both as how the universe arranges events so that they can exist at all. This idea feels abstract only until its consequences are felt. For a long stretch in our history, people pictured space as a fixed stage and time as an absolute drumbeat that never changed tempo. The play unfolded on a stable floor. The drum ticked for everyone everywhere, and that was that. Then a new picture arrived, patient and precise, and it asked us to loosen our grip. In that picture, space and time are not stiff but supple. They can stretch and gather, tilt and ripple, and they do not stand indifferent to matter and energy, but respond to them. In this view, gravity is not a hidden hand tugging at you from a distance. It is the shape the fabric takes when mass is present. A heavy body does not shout commands. It simply changes the floor beneath your feet, and everything nearby follows the new lines without being told. To feel this more clearly, return to that quiet sheet in your mind. Let it be smooth for a moment. Then place something heavy at its center. The surface dips. The lines that once ran straight now curve toward the depression. This is the way a star or a planet rests in space-time, not hovering in an empty box but changing the space and the time around it. If you roll a smaller ball near the dip, it does not veer because an invisible rope pulls at it. It veers because the straight path it prefers is no longer straight. The shortest route wraps toward the heavy body, and what you experience as attraction is simply obedience to geometry. In everyday life, we call that obedience gravity. The little ball is both invited and nudged by the shape of the fabric itself, and its motion is a record of the curves it cannot help but follow. Because space and time are one fabric, the bending is never only about distance. Where the sheet sags, the tempo of time changes too. The same dip that guides a planet's orbit also touches the rate at which seconds pass. Near a heavy mass, the local rhythm of time runs a little slower. Farther away, it runs a little faster. There is no single universal drumbeat that keeps perfect time for everyone. There are many rhythms, each set by the landscape of space-time that a traveler moves through. This is why a journey toward the future, faster than the pace of those who stay behind, is not a fantasy, but a quiet consequence of how the world is stitched. Change your speed enough, or rest in a place where gravity is strong enough, and your clock will tick more slowly, compared with a clock far away in gentler conditions. When you return to share the same room, you carry a few more seconds saved or spent, depending on how you like to think about it. The principle is not a rumor. The challenge is to reach the speeds and fields that make the difference large enough to feel in a human life. The recipe sits on the table. The ingredients are simply hard to gather. The past is a more delicate shore. To wonder whether a moment already lived could be visited again is to feel both curiosity and caution. Some paths through the fabric, if they exist and can be held open, look like tunnels that connect distant places and perhaps distant times. We call them wormholes. When we sketch them, and even in sketch form, they ask for materials and conditions that push against what we can manage. Alongside the hope they carry, there is a chorus of warnings about loops that twist cause and effect into knots, puzzles where an action erases its own reason, and stories that tangle so tightly they may not be allowed by the deeper order of things. The questions are not forbidden, they are simply tender and must be held with care. Move your attention back to the image of the fabric and notice how all these ideas belong to the same picture. Space-time can stretch and compress. It can sag under mass. It can ripple like a pond when something energetic happens far away. Objects do not sit on top of it like furniture. They are part of it. Their presence writes geometry, and geometry writes their paths. When the fabric leans, even time leans with it. There is no master clock in the sky. Only many clocks keeping time with their surroundings, each one honest in its own neighborhood. In this gentle light, the question of what time is no longer feels like an argument to win. It feels like a landscape to sit with, a coastline to watch as the tide moves in slow breaths. You can trust the calendar to set a lunch date and still recognize that beyond the careful squares is a deeper weave that does not care about our schedules. You can honor the way minutes pass in your kitchen, and also the way minutes pass differently near a massive star. Both are true inside their rooms. Hold again the thought that began our walk. Time is not a thing you can tuck in your pocket, yet it touches every pocket and every thought you have. It arranges the order of moments so that a cause can find its effect, and it lets you feel the difference between before and after. It allows stories to have beginnings and endings, and it permits you to rest in the tender stretch between them. When you ask whether it flows, you may find that flow is only one way to sense it, the way a river looks from the bank. From the water's own view, perhaps there is only the shape of the channel. If you listen now to the clock in the next room, the sound is the same as it was before, but what it means may have softened. Each tick is still a step, and yet the floor under those steps has become a living surface, a field that bends around weight and speed, a fabric that holds galaxies and teacups with the same quiet law. The idea that gravity is not a pulling hand but a curving road, that the future can be reached a little sooner by moving a little faster or nestling closer to something heavy, that the past might be glimpsed only through careful doorways that may never open without untying logic itself. All of this lives inside one simple picture that you can carry without strain. Let the picture drift with you as the night deepens. The universe is not a rigid stage, but a soft, resilient cloth, and you are not only an actor on it, you are a thread woven in. Where the cloth curves, you curve. Where time slows, your heart keeps its own patient pace, unconcerned with anything except the next breath. If you return your gaze to the clock, do it gently. It has not changed, and yet it has. The sound it makes is still the same sound, but beneath it there is a quiet you can hear now. The quiet of a world where space and time are one, where gravity is the geometry of being, and where the rhythm you live by is local and honest and yours. In that quiet, the promise hidden in the earlier questions remains simple. To arrive in the future a touch early is to ride a known slope in the fabric. To step into the past, if such a step is ever allowed, would require a different kind of passage, one that does not tear the cloth or knot it beyond repair. At the far edge, where our rules blur and our courage grows careful, sketches of machines appear like pale chalk on dark slate. They are not commands, they are invitations to understand the shape of the road rather than to force a destination. The meaning is not conquest, it is comprehension. Stay with the breath that moves through you and with the soft ticking that keeps you company. Time has always been here, not outside you but with you, shaping the order of your days and the music of your memories. Knowing that it is woven with space, that gravity is the curve of that weave, that clocks are honest yet local voices, may be enough for tonight. The rest can wait, and perhaps in the waiting you will find that you hear the clock differently. Not louder or softer, but truer, like a familiar footfall on a path you have finally begun to notice. What becomes most curious, once the lights dim and the mind grows quiet, is how the physics itself refuses to pin little labels on the moments we feel so clearly. Past, present, future are the names we give to our experience, familiar and comforting, like street signs in a neighborhood we know. Yet the equations that guide gravity never attach those signs to the road. They describe how time stretches and curves alongside space, how it shares the same fabric, but they do not circle a moment and say this one is now. They draw the map without arrows, leaving us to feel the breeze that seems to move along it. In that map, time is counted as a dimension, kept beside length, width, and height, another coordinate that specifies where an event belongs. A place can be told by distances in 3 directions, and an occurrence is told by a 4th number that marks when it happens. Put the 4 together, and you have a location in spacetime, a full address for a star's flare or a whispered word. The structure holds them all at once, quiet and complete, as if every bead on the string is already threaded and simply waits for the hand that will slide over it. Yet, there is a gentle difference you feel as soon as you listen to your own breathing. You can turn left or right, step backward or forward, climb or descend through space. Time does not let you wander so freely. You live in one instant and then the next, never both, never in reverse. In the mathematics, though, every instant simply exists. The writing on the page does not fade once you read it. The page is just part of the book. The theory keeps no special shelf for now. It offers a tapestry laid out all at once, and whatever we call the present is only the stitch our attention is touching. From that picture, a quiet, unsettling idea glows. Perhaps time is not a river that flows past us. Perhaps it is the riverbed, already there from source to sea. Every moment is part of the same ground, like towns along a coastline, all real at once whether or not our feet have reached them. We taste each one in order because that is how our minds move, not because the coastline appears and disappears. When Einstein wrote to a grieving friend, he suggested that the boundary we draw between before and after feels stubbornly real to us, yet may not be built into nature itself. He did not say time is a fairy tale. He suggested the feeling of flow could be a gift of perception, not a law of the world. If that is so, a cluster of familiar questions rises like birds from a tree. Why do memories point backward and never forward? Why does a broken cup not leap together from the floor and find your hand again? Why does warmth seep from hot to cold and not return on its own. If the basic rules do not prefer one direction, where does the sense of direction come from? This is the riddle people call the arrow of time. A quiet arrow we all feel even if no equation draws it. To look for the arrow, physicists set gravity aside for a moment and lean toward thermodynamics, the study of heat and energy. There, a rule shows itself that is as patient as the tide. In any closed system, the total disorder, called entropy, tends to grow. Order gives way to mixture. Neatness loosens into scatter. Patterns blur into averages. You can watch it in a kitchen without any math at all. Drop an egg and you will see shards and a spreading pool. It is not that the laws forbid the reverse. They allow it. But the reverse would require an astonishing choreography of pieces arranging themselves just so. The odds are so thin they might as well be a whisper across a canyon. What we see, what we trust, is the relaxed drift from arranged to disarranged. The same quiet rule shows up wherever you rest your gaze long enough. A star burns its ordered fuel and slides toward ash and light. Ice warms to water and then to air if you let it be. Perfume creeps from a single point to fill a whole room. The universe itself expands, the average state spreading and cooling as if the great fabric were exhaling. In all of these, entropy rises, and that rise puts a soft arrowhead at the end of time's shaft. It gives us a language for before and after that does not come from gravity's equations, but from how the world is set and how it tends to relax. A picture helps, one that moves gently across the mind. Imagine a book at rest on a table. Every page exists at this moment, page 10 and page 50, and the last page as well, all printed and bound. You, with your patient hands, still read in one direction. The book does not force you to turn forward. Your story does. In the same way, the space-time picture holds every event, yet the rise of entropy nudges experience along a path that feels forward. The direction is not stamped onto the pages. It is written into the unfolding of arrangement into looseness. Because we know this, we can spot when the direction is being faked. If you film the egg shattering and then run the film backward, the scene pricks the skin. It is not just unfamiliar, it presses against the deep rule. Liquid gathers and climbs, shards lift and join, and a whole egg pops into your hand. Your body knows something has been inverted, because the path returned from mixed to neat, from many disordered possibilities to one precise arrangement. This is why a reversed waterfall looks uncanny, and a reversed match looks unreal. We are sensitive to the sign of the flow. Underneath, the equations that govern the tiny pieces often make no fuss about direction. If you swap forward for backward, they still balance. They do not insist that the egg must break, only that if it does, the reversed dance would demand a coordination so perfect that the slightest nudge would spoil it. The error we feel, then, is not demanded by the deepest rules on their own. It emerges from how things are arranged, and from the extraordinary unlikelihood of going uphill in the landscape of possibilities. The world began in a state of astonishing order compared with what is available to it, and it has been relaxing ever since. This view does not take away the feeling of time's one-way drift. It explains why that feeling is so steady. We remember the past because information has flowed from a concentrated state into a more spread out one and left traces behind, like footprints in wet sand. We do not remember the future because there are no traces laid down yet by events that have not scattered their pieces. Broken cups remain broken because it is so much easier, in terms of arrangements, for bits to wander than to gather themselves perfectly. Heat moves from the warmer object to the cooler. because there are immensely more ways for energy to be spread than to be perfectly concentrated again. The arrow is the way probability leans when countless parts take their countless paths. Set alongside the block-like calm of relativity, the arrow adds warmth and texture to the picture. The fabric of space-time may hold all events at once, with no preferred now, yet the stories written inside that fabric have a direction because the ink spreads. We are the kind of beings that ride those stories. We do not step outside the book to look at all the pages at once. We turn them with hands that live in a body, and the body is made of parts that follow the drift from order to disorder. The personal sensation of moving along a single thread is not an illusion in the scornful sense. It is the honest report of a traveler whose path is shaped by entropy's slope. Something gentle follows from this. The present is not as singular as it appears when you look at a clock, and the future is not a locked room sealed against you. The past is not entirely gone either. It persists as patterns in memory, in photographs, in fossils and starlight, all consequences of the same spread from neat to mixed. The laws underneath are generous enough to allow time to be walked backward in principle, yet the world we inhabit is so richly populated with moving parts that backward paths are swallowed by the odds. Between the severe purity of the equations and the soft, grainy reality of a life lived, there is a harmony. One tells you what is allowed, the other tells you what is likely. Let your attention rest again on the quiet notion that began this stretch of thinking. Physics does not crown a moment and say, "This is now." It offers a whole field where events are placed. Our minds, sewn into bodies that warm and cool and scatter their arrangements, provide the feeling of drift. Thermodynamics supplies the arrow that the geometry does not. Together they make the world we know. A universe whose deep rules are time-symmetric in many ways, yet whose large assemblies of matter and light lean relentlessly toward the ordinary miracle of mixing. With that in view, the question that has been waiting at the edge of our walk comes back into focus without hurry. If time can curve with space, and if entropy gives time its direction, is there a path that allows a traveler to move differently through the field than a neighbor does? We already know how to arrive in the future a touch early, by changing speed or by resting in stronger gravity. The steps are small in a human day, but unmistakable in the language of clocks. The more daring thought reaches toward the past, toward doorways hinted at in some solutions to the equations, passages that would need to be held open against collapse, routes that raise paradoxes like shy animals in the brush. The laws do not slam the door, yet they fill the hallway with conditions and cautions. For now, it is enough to feel how the compass works. The labels past and future are not written on the sky. They are written in the spreading of patterns, in the way brokenness is easy and perfect reassembly is not. The present is the place where your body reads the page it is on, sentence by unhurried sentence. If you step outside to listen to the night, the same rule hums in the cricket's song and in the slow cooling of the stones. The universe keeps its book whole, and you make your way through it, steady as a tide, guided by an arrow that is soft to the touch and firm in its direction. In October 2005, a quiet figure dropped back through the blue and came home. Not just any traveler, but someone who had learned the rhythms of orbit the way sailors learn the pulse of a tide. Sergei Krikalev had threaded himself through nearly 2 decades of launches and returns. 6 journeys that added up to 803 days, 9 hours, and 39 minutes away from the ground. More than 2 years of sunrises that arrived every 90 minutes. More than 2 years of Earth turning beneath a window like a living map. His path began in 1988, when the Cold War still filled the air, and a Soyuz named TM-7 carried him upward to Mir, the bright outpost that marked the height of Soviet flight. He went back to that station again, a worker among humming panels and handrails that led from airlock to experiment rack, like threads in a familiar room. Months at a time, he floated rather than walked, ate from packets that drifted before they were caught, slept in a bag that kept him from gently pushing off the wall with his own breath, calm under pressure, careful with tools, patient with long spans far from family. He became the person you wanted aloft when something creaked or flickered. In 1991, while he circled above, the country printed on his passport dissolved. Borders and flags rearranged themselves on the ground, and he kept the station healthy, a citizen between names, keeping watch while nations shifted like clouds. The years turned, and the story of spaceflight softened from contest to cooperation. He rode the shuttle, learned the cadence of English call-outs beside Russian ones, and helped stitch the first pieces of a new home in orbit into a working whole. In 2000, he flew on the first expedition to the International Space Station, a beginning made of hard corners and hopeful routine. In 2005, he returned for a sixth mission, moving through modules he knew by touch, and the tally on the clocks crept past 800 days. A world record at the time, a quiet mark set not with fireworks, but with steady work and many orbits. Holidays passed with small decorations taped to bulkheads, with toasts that drifted in pouches, with calls home that traveled through satellites before a familiar voice answered. Experiments grew and finished. Muscles learned how not to waste away. Cameras captured cities at night, lightning crawling across clouds, auroras that looked like curtains burning without heat. Somewhere inside those many loops around the planet, a softer truth was taking shape. Krikalev was not only a traveler in space, he was, in a precise and modest way, a traveler in time. The reason is not magic. It is the quiet rule that faster motion slows the local pace of time when measured against a clock that stays behind. In low orbit, he moved at about 7.66 kilometers each second, close to 27,600 kilometers each hour, a speed that pulls you into almost 16 sunrises a day. According to special relativity, the body and the onboard clock at that speed tick a little more slowly than the ones kept still on the ground. For every second that passed for his friends and family below, a fraction less slipped by for him. The difference is small, too small to feel as you strap in or sip tea, yet it accumulates. Across 803 days, the total tucked away into the numbers came to about 20 milliseconds. A sliver of a second, yes, but real enough to count. When he returned, he was that tiny amount younger than he would have been if he had never left. He had moved into the future of Earth's timeline by living slightly slower, so the rest of us were the ones who hurried ahead. He did not sprint into tomorrow. He drifted there while we ran. To see why, it helps to imagine two extremely patient clocks. They are identical and absurdly steady, the kind used in laboratories to keep time with atoms rather than springs and gears. One stays where you are. The other rides a fast loop around the world and then comes back to sit next to the first. When the hands are compared after the journey, the traveler's clock has fallen a little behind. The effect is not a rumor. It has been measured so often that engineers quietly correct for it whenever a satellite is part of a system that must keep faith with time on the ground. A famous check, simple in outline and delicate in practice, took place in 1971. Joseph Hafele and Richard Keating carried atomic clocks on commercial flights around the world, and then brought them home to compare against clocks that had not left. The differences were tiny, and exactly the kind you expect when motion slows the traveler's time. Military planes have done similar work. The satellites that help your phone locate the nearest street corner use clocks that tick at rates adjusted for both speed and altitude, so that their time and our time do not slowly drift apart. When you move very fast, your own seconds lengthen compared with the seconds of someone who stays still. The nearer your speed drifts toward light's pace, the more your personal clock relaxes. So a trip that feels short to you can add up to much more time for those waiting at home. Let the symbols rest rather than rush past. The meaning is gentle. As the traveler's speed approaches the speed of light, the denominator shrinks, the whole fraction grows, and the traveler's own seconds stretch out when compared to the seconds kept by a person not moving so fast. In ordinary life, we do not notice because our cars and trains and planes are still slow when measured against light. In orbit, the difference is small but measurable. Closer to light speed, the change becomes dramatic. A thought experiment can be held like a warm cup in both hands. Imagine you board a ship that can move at 99.9% of light speed. You take a long trip, long enough that your onboard clock counts a single year. When you return to the home you left, decades have slipped by. The people who waved at the launch pad have grown older and perhaps are gone. From your seat, you did not feel stretched or squeezed. Your heart kept its calm beat. It is the comparison, when you step back into the old garden and look at the calendar, that reveals what you have done. Your path through time was slower than theirs, so you arrive in their future while having aged so much less. You did not force yourself into tomorrow. You changed the way your seconds accumulated. If the scales feel heavy, soften them with a picture. Imagine everyone at home watching a film at the normal pace, and you are watching the same film in slow motion. As minutes pass, the scenes for them roll forward, while for you the motion lingers on details, every gesture stretched. When they reach the credits, you are still deep in the middle. The film itself is the same. The rate at which you move through it is not. Moving near light speed is like choosing the slower setting, a pace that turns hours into days for those who stayed behind. Back in the real world, the International Space Station circles within the thin shell of our planet's gravity. There is another effect to mention, one that points in the opposite direction and still fits quietly into the whole. Time runs a little faster when you rest farther from massive bodies, because the pull that bends paths also bends the local rhythm of seconds. In low orbit, both influences are present at once: speed that slows the ticking, altitude that slightly quickens it. The balance depends on the height and the velocity. For the station's path, the slowing from motion wins the contest. So the traveler returns a few milliseconds shy of the earthbound tally. It is a gentle reminder that the world's rules overlap and add, sometimes canceling, sometimes reinforcing, always keeping careful account. Krikolev's story, held in this light, becomes a human way to feel equations that can seem distant on a page. A person left a plane of air in cities, lived among panels and handholds, spoke to distant voices through relays that skimmed the horizon, and came back a whisper younger than he would have been. No special rituals, no flashes of fantasy, only the steady discipline of orbits and the quiet stubbornness of clocks. From this vantage, questions that once sounded huge can sit beside you without strain. If speed can slow a personal clock, how far could that principle carry you? A ship that sips energy well, guided along a path that allows long periods near light speed, becomes a way to move far into someone else's future with only a modest burden of years. For you, the universe remains patient with such travelers. It does not protest or punish. It simply keeps each path honest. You might return to the image of windows looking out on Earth, a blue curve slipping under a dark border, sunrise arriving like a soft switch turned to bright. Inside, a schedule floats on the wall. Work periods, exercise to keep bones from forgetting their job, calls home, maintenance to keep filters clean and valves smooth. Outside, stars stand still when the station is in shadow, then disappear in the glare. In that setting, time is a companion as real as any crewmate. It is in the breathing, in the data logs, in the growing list of completed tasks. Yet, in the sums kept quietly by relativity, those same hours slide by just a breath slower than the ones kept by the clocks you left behind. Experiments with clocks make the idea precise. Stories like Krikolev's make it warm. One thread is numbers on a graph. The other is the sound of a voice calling down from orbit on a holiday. Place them together and the picture steadies. A person can be both an engineer adjusting valves and a tiny traveler into tomorrow, simply by being where they are and moving as they must to remain aloft. If your thoughts wander toward the extreme again, let them move without hurry. Near light speed, the difference between a traveler's calendar and the calendars left behind becomes the stuff of novels. Yet, it remains rooted in a plain relation between speed and the measure of time. You do not need to memorize symbols to carry the sense. Faster motion means a slower personal pace when compared against the world you left. Long enough and fast enough, and you can step off the ship into a year that used to be a distant dream for those who stayed. There is comfort in knowing that the universe holds such possibilities without drama. No door slams, no special permission is required, only the means to reach the speed and to endure the voyage. There is also comfort in the smallness of what has already been done. 20 milliseconds tucked away by a patient cosmonaut are not much, yet they are a real piece of the same story. Between the soft tick of a clock on a nightstand and the quiet beeping of a timer on a station's console, the same idea holds. Think of time as a companion that listens rather than instructs. Krikalev moved quickly, and so his companion spoke a little more slowly to him, and when he returned, the rest of us had rushed ahead by a hair. 2 lives measured side by side, 2 clocks set together, 2 paths through the same world, and a difference small enough to be tender. That is all time travel needs to be, at least for now. Not a thunderclap, but a subtle shift, like the way your pulse feels different after a run, and then settles as you rest. If you imagine yourself looking out one of those windows, seeing the curve of home again and again, you might notice how the mind keeps its own count, separate from any instrument. Days are made from tasks completed, from greetings exchanged with ground controllers, whose mornings and nights are never in step with yours, from the way sunlight sweeps the cabin and then slips away mid-sentence. The body adapts. The clock on the wall keeps station time, and deep in the mathematics that describe motion, your own seconds gather at a slower pace. Later, when you step onto a runway and feel weight the way you used to, the numbers will show what your skin could never feel. A small difference that proves a larger truth. If this feels like a secret whispered by the universe, that is because it is quiet by nature. Special relativity does not shout. It sits beside you like a steady friend and reminds you that motion changes time's measure, always by the same rule, always with the same patience. The story of a man who watched the world turn from above, who worked inside humming rooms and came home a sliver younger than his waiting self on Earth, gives the rule a face. It lets the idea breathe, and so the path unfolds without fanfare. A person goes to orbit, lives there, returns. Clocks are compared. The difference is written down. Somewhere, a spreadsheet is updated. Somewhere else, a listener smiles at the thought that time can be shaped by speed. Both are true. Both are part of the same gentle lesson. The universe is not only vast, it is intimate with those who move inside it. It keeps careful track. It allows small miracles, measured in milliseconds or in decades, depending on how far and how fast you go. Not only speed bends our experience of time, the quiet weight that keeps feet on the ground reshapes it too, though not in the way a simple tug would suggest. In Einstein's deeper view, gravity is the geometry of space-time. Mass doesn't reach out with a hand. It presses into the fabric, and the fabric curves. Where the curve grows steep, seconds stretch, move nearer to a massive body, and the local tempo of time softens. Step away, and the beat quickens again. Physicists call this gravitational time dilation, and it carries both the elegance of mathematics and the hush of a tide turning. Picture a wide, dark cloth spread beyond any horizon, studded with stars and warmed by nearby worlds. A planet rests on that cloth, and the threads draw down around it. The ground you stand on is shaped by that curve, and so is the rhythm of your wristwatch. The image grows starker near extreme masses. Storytellers have shown this with a clarity that lingers. A ship slipping close to a black hole, a crew touching down on a world that circles danger too tightly. Each hour they spend beside the surf becomes 7 years for those far away. Not sorcery, not a cheat, just space-time pulled taut by gravity until time crawls. Returning to orbit, the human cost arrives without fanfare. A crewmate who waited in the safer drift meets friends who are hours older, yet he has aged decades. The equations predicted the slow drip of time near such weight. The faces on screen translate that prediction into ache. A nearby black hole named Gargantua earned its realism from careful hands. Kip Thorne guided the model so the horizon's light, the lensing, and the clock's behavior would honor general relativity. When the laws are kept, the story deepens instead of breaking. The same rule whispers on Earth. No monstrous gravity is needed to reveal it. Precision will do. During the 1,970 seconds, 2 atomic clocks that agreed to the last tick were separated by altitude. One stayed close to sea level, wrapped tight by Earth's pull. The other rode to a mountain summit, roughly 2,300 meters, about 7,500 feet above the sea. 11 days later, comparison showed the high clock had gained a few billionths of a second. Higher means weaker gravity. Weaker gravity means a gentler curve. A gentler curve means time moves a shade faster. Lower means stronger gravity and slower local time. The difference is delicate, but instruments notice what bodies can't. Orbiting technology hinges on this same patience. Systems that guide navigation, synchronize networks, and map the world rely on clocks aloft and clocks on the ground, agreeing in spite of gravity's sag and speed's stretch. Engineers fold Einstein's corrections into the code, nudging the ticking so that maps line up with streets and distant receivers find their way. The theory that bends horizons also keeps your phone honest. From gravity's slow hand, the mind drifts to an idea that seems impossible until the math is written down. Instead of urging a ship through space the way an engine pushes a car down a road, what if the ship stayed still inside a small pocket of space and the pocket moved? In 1994, Miguel Alcubierre used general relativity's language to draw such a pocket, changed the space-time metric, the rulebook. that tells distances and durations how to behave so that a compact region of space contracts ahead and expands behind. Inside, the ship rests, feeling nothing unusual. Outside, the bubble slides across the cosmos. Surfing offers a good analogy without noise. A rider balanced on a wave is carried shoreward by moving water while standing nearly still relative to the wave itself. In the Alcubierre picture, space-time plays the role of water. The bubble doesn't demand that the craft move faster than light through local space. It moves the space. By sidestepping the rule about motion through the medium, the design promises journeys that outpace any beam while keeping the traveler's minutes ordinary. Time inside the bubble would remain gentle. Months for the crew could correspond to centuries beyond the rim. An expedition might leave a familiar century and arrive at a distant star within a personal year, only to learn that the calendars back home mark a date 1,000 years ahead. No crushing acceleration would trouble the bones, no shock from sprinting through dust. Grains at relativistic speed would batter the hull. Because the ship wouldn't be plowing through space, it would be nestled within it. The catch sits in the kind of energy required to sculpt space-time so boldly. Ordinary matter and light curve the fabric in one direction. The drive Alcubierre described needs pockets that curve it the other way. Negative energy, or exotic matter, enters the conversation here. Quantum theory tolerates tiny, temporary deficits of energy. In constrained regions, a narrow gap between metal plates, for example, slightly alters the vacuum's jitter and produces a measurable force known as the Casimir effect. Turning those faint, fleeting phenomena into stable reservoirs large enough to frame a starship-sized bubble is another matter entirely. Even so, curiosity did not stop at the page. At NASA's Eagle Works, Harold Sonny White explored refinements that changed the bubble's geometry. In his sketches, clever shaping of the ring around the craft lowers the energy budget by orders of magnitude down from planetary scales towards something closer to a vehicle's mass energy. On paper, that is a breathtaking improvement. In practice, the distance from car-like energy to extractable, controllable negative energy is a canyon with fog at the bottom. Reducing the arithmetic burden does not conjure the substance required, yet it shows the theory has knobs to turn. Additional cautions cluster around the edges. Boundaries in space-time can behave like rough surf. Some analyses suggest a warp bubble would collect intense quantum radiation, storing it at the front edge like static on a balloon. Stabilizing such a structure, steering it, and shutting it down safely pose puzzles that cannot be waved away. There is also the problem of causality and communication. Starting or breaking a bubble may demand information from the destination region that cannot arrive in time without violating the very limit the construction seeks to respect. These are not final verdicts. They are signposts along a road that is still mostly sketched. What keeps the Alcubierre idea in the conversation, despite these obstacles, is how respectfully it treats the underlying law. No new fundamental forces are demanded. No rule against superluminal local motion is broken. The design moves space itself and, in doing so, sidesteps the speed limit within space while honoring general relativity. That is a narrow path, and narrow paths can be real. Gravity's gentler demonstrations deserve the same attention as its spectacular ones. Raise a clock by the height of a tall building, and it gains on its twin at the lobby by a sliver. The effect is that consistent. Spread 2 clocks from head to foot, and the higher one, by the tiniest margin, races ahead. These differences are unimaginably small in daily life, yet the precision of modern timing can sense them. The result is a world where skyscraper observatories mountain observatories, and satellites each keep time according to their place in the curve, and the harmony among them becomes a quiet triumph of theory meeting practice. Back near a black hole, the geometry pushes into extremes. Close to the event horizon, the time measured by an observer far away stretches toward infinity. A clock, carried into the fall, appears to slow and halt from the distant watcher's perspective. For the falling traveler, the crossing happens in finite time, indifferent to the audience. Two truths coexist: the local story inside the plunge, and the far-field story written by light that struggles to escape. The same theory that predicts a star's orbit also predicts these vertiginous views, tying everyday gravity to the brink of the unreturnable. Across all these examples runs a simple tune. Gravity is curvature, time is part of the curve. Speed changes the personal rate at which moments accumulate. Altitude changes it too. Add one effect to the other, and the combined tempo tells clocks where they stand. Think of a cosmonaut circling at high speed yet higher above the ground. Then city streets, the two influences compete, and the scoreboard decides which wins. For low Earth orbit, motion's slowdown dominates. For high-altitude satellites, weaker gravity's speed up can overtake motion's slowdown. Engineers account for both, not because philosophy demands it, but because maps otherwise drift and signals arrive out of step. Curiosity about travel grows naturally from these patterns. A person can already slip into the future by choosing a route that lingers at high speed or crosses higher gravitational potentials. The effect is tiny for commercial flights and measurable for satellites. It would become dramatic only with technologies that push speeds close to lights. A craft that can endure such speeds turns decades for those at home into months for those aboard. Nothing mystical occurs. Each clock stays honest to its path. The warp bubbles sketch belongs to a different family of dreams. Instead of playing near the limit, the design rewrites the playground's shape. Contracting space ahead brings a destination nearer without asking the ship to hurry. Expanding space behind carries the ship forward without a shove. The travelers' hearts keep a calm beat. Cups rest quietly on a table, and a window shows stars shifting in a way no ordinary voyage could produce. On arrival, diaries record modest time spent. Outside histories record centuries. Even described this way, the idea remains an invitation to imagine rather than a program to build. Exotic matter must be found or forged, stability mastered, horizons managed, so information and energy behave. In the meantime, the Earth continues to turn, and the same laws shape small wonders. A mountaintop adds a sliver to a clock. A valley subtracts. The sea tugs at the body with a steady hand. Planets and stars write their weight into the paths of light. The geometry that cradles galaxies also visits a laboratory bench, where metal plates create a barely there pressure from vacuum's restlessness. Between those scales, a patient continuity holds. One story, many chapters, no broken lines. Breathing settles into a cadence that suits the hour. The notion that time is elastic no longer feels alarming. It becomes a kind of kindness. Local conditions decide the rate at which moments arrive, and instruments are sensitive enough to keep the peace among different rates. There is a dignity in that arrangement. The universe allows subtle differences and still grants harmony when care is taken. Clocks, in this light, are more than devices. They are listeners. Place them near a heavy mass, and they report a lower tempo. Raise them into thinner gravity, and they answer more quickly. Set them moving, and they stretch their seconds when judged against those who rest. None of the devices knows or cares why. They keep faith with the fabric. Human stories, cosmonauts circling, crews waiting, scientists comparing readouts on mountain summits, give the measurements a pulse and a face. Travelers of the future may stand on decks that never jolt, while vacuum slides past a ring of shape space-time. They may step off into years that did not exist when they left their home ports. Between the far edge of that vision and the soft edge of tonight sits the work of generations. Deeper understanding of quantum fields, new ways to manipulate energy without tearing what supports us. Better instruments that can hear whispers in the hum of reality. The laws already on the books are roomy enough to host such efforts. The limits are practical, not philosophical. Speed, gravity, and geometry weave a quiet trilogy. The first stretches personal time against a neighbor's. The second tunes the local tempo according to height above mass. The third suggests routes in which space itself does the traveling. Take any one of these in isolation, and the result is intriguing. Place them together, and the picture turns serene. A universe that is rigorous and forgiving, precise and somehow humane, where stories of seconds can be told at many scales without contradiction. Standing by a window at night, it is possible to feel the shape of these ideas without solving anything. The ground holds firm because space-time curves around Earth. Distant stars shimmer because their light crosses long, bent paths. The watch on a bedside table keeps time. That is true for this room, this altitude, this motion. A satellite reads a different page of the same score and adjusts so that both stay in tune. Far away, theories about bubbles and waves wait in notebooks, patient as seeds. Hours pass whether noticed or not. The same is true of the laws that move with them. Gravity slows time near weight and quickens it away from weight. Speed stretches moments in the traveler's frame. Space-time can be curved gently by mountains or fiercely by black holes. And perhaps one day it will be shaped with enough finesse to carry a human ship as a river carries a leaf. The story asks for no vows beyond attention. The fabric does what it does, faithful and consistent, with or without our names for its motions. Even without the soft commands of let and if, the invitation remains. Rest where you are. Notice how these ideas settle when spoken quietly. The world has room for them. So does the mind. And as breath slows, the thought that time is not rigid but responsive, woven with space, tuned by gravity, pliable under extreme conditions, becomes something you can almost feel on the skin, like faint wind from a distant sea. Some doors in the universe seem to open inward and never let go. Others, in the mathematics that guide gravity, appear as their mirror image, opening outward with a fierce and constant breath. A white hole is that second kind of door. Not a mouth that swallows, but a fountain that refuses entry. A source that throws matter and light outward instead of pulling them in. It sounds like a riddle until you trace the lines back to general relativity. When the equations that describe a black hole are read in a time-reversed way, they admit a sibling solution that behaves like a black hole turned inside out. Where a black hole permits crossing in and forbids escape, a white hole forbids crossing in at all, forever pushing the world away from its threshold. This picture is not an invention of fiction writers. It arrives from the same family of solutions that gave us the black hole itself, the quiet geometry that tells space and time how to curve around mass and energy. In that geometry, the white hole is a possibility, a structure that would act as an unapproachable source. No ladder descends to its heart. No probe can be guided through its glare. Approach is denied, ejection is guaranteed, and the flow points outward like a spring that never runs dry. Connections deepen the intrigue. Some researchers have explored whether a white hole could be paired with a black hole by a tunnel through spacetime, the passage we call a wormhole. The idea is shy and demanding all at once. Near a black hole, the warping becomes extreme. The pull grows to a crush, and any ordinary traveler would be stretched and undone long before reaching anything like a tunnel's calm. Yet, on paper, certain solutions hint at routes where entry through a black hole might end at a white hole's mouth. In such a route, the way time stretches inside the black hole could translate to a leap on the outside. Minutes or hours for the traveler, centuries for the world that watches from safer distances. Picture it only long enough to feel the scale. A step taken in 2025 toward a black horizon, an emergence in 4025 from a bright, repelling mouth. From the traveler's point of view, only a short ordeal. From Earth's point of view, 1,000 quiet years. The path is one way, a cannon that fires a person into the far future and refuses a return shot. The traveler does not carry a switch to come back, and the white hole does not offer a door to re-enter. A time machine of that sort would not loop or rewind. It would fling. Against this elegance stands the quiet verdict of observation. Black holes announce themselves through orbits and light. They bend starlight, heat disks of gas, merge and ring like struck bells. We have even made images of shadows against glowing matter, including the famous view in the galaxy M87. White holes have left no such trace. No astronomer has caught one in the act. Opinions divide. Some physicists keep the concept in a careful drawer, a mathematical cousin that nature chose not to build. Others speculate that white holes could exist under extreme conditions, or stand as relics of the youngest universe, fossils of an era when densities were beyond imagination. The ledger remains empty of confirmation. Wild guesses have tried to connect white holes to brief, blistering lights in the sky. Gamma ray bursts, for example, arrive as intense flashes of high-energy radiation, some lasting only a short breath. A few papers have floated the thought that such bursts could be white holes discharging energy. The sky has not agreed to that story. Evidence is thin, and other explanations, tied to collapsing stars and violent mergers, carry more weight. For now, white holes remain a possibility in the mathematics, rather than a presence in the night. Their allure endures anyway. A source that cannot be approached. A fountain that might empty a traveler into a later century. A tunnel that connects an inescapable fall to an unenterable rise. The mind holds the shape even if the sky offers no specimen. Dreams of far futures do not always require horizons and tunnels. There is a humbler route that people, flesh, and hope are already attempting. Instead of asking space-time to carry you, the plan asks you to wait, not in a rocking chair, not with a calendar, but in cold so deep that biology falls silent. Cryonics turns the question inside out. Rather than speeding your time or bending the world's time, you try to pause your living processes and trust that other hands, in another age, will know how to restart them. The outline is straightforward, even as the practice is tangled. A person dies by the measure of law. Immediately, a team moves to cool the body so that decomposition and chemical damage slow. The goal is to lower temperature quickly, to halt the motions and reactions that, in warm tissue, unravel structure. Eventually, the body is brought to the neighborhood of liquid nitrogen, around -196 degrees Celsius, and stored there, still as stone, in a tall, silvery tank. The intention is preservation, not resurrection today. Brains, organs, cellular arrangements, All are meant to be held in place long enough that a future with better tools might reverse what now seems final. Among the names associated with this wager, James Bedford appears early. He was a psychology professor who died in 1967 and became the first human subject of this approach. His body was cooled and preserved, and by that act he moved himself into a strange status, neither here nor gone in the usual sense, waiting in a metal cylinder while decades accumulated around him. Others have chosen the same path. Some have selected full body preservation. Others have arranged for only the head to be stored, carrying a belief that future techniques might regrow or reconstruct a body to match a saved brain. There is a sobering ledger beside these hopes. Revival is beyond current knowledge. No one has returned a human being from this kind of preservation. Ice crystals can form during cooling and slice through delicate structures. Chemical preservatives, introduced to protect against ice, can themselves injure cells and alter proteins. Even if the freezing could be made gentle enough to avoid mechanical damage, the thaw would have to remain controlled across a body or a brain with countless different tissues, each with its own needs. Warm too fast and conditions become chaotic. Warm too slow and other harms creep in. The goal, sometimes described as vitrification, aims to replace ice with a glass-like state that avoids sharp crystals. But even that technical word does not erase the scale of the task ahead. The truth, told softly, is that cryonics today is a gamble on tomorrow's science. People who choose it are buying a very long ticket, not in currency but in faith, that future researchers will learn how to repair what freezing and time have done. They also bet that the society they wake into will welcome them, will have room, will have reasons to care. There is courage in that bet, perhaps also a bit of longing. It is not a shortcut around physics. It is a wager on community and continuity, on craft and compassion. In a personal sense, the mechanism counts as genuine time travel, without moving at relativistic speeds or skimming the edge of a black hole. A person could leave the world on a winter evening and open their eyes in a century with different skies. No time would be felt between the two. One heartbeat here, the next heartbeat there. With the long middle erased, the calendar would race while the person stayed still. Plan a preservation in the present and, in the best version of the story, wake in the year 2500 to rooms and languages and stars arranged by hands you never met. The life in between would be for other people. Your own life would hop across it like a stone. Companies exist that offer this preservation. They watch for the legal moment of death, begin cooling quickly, infuse cryoprotective substances to slow and modify ice formation, and lower the temperature until motion stops everywhere. Then, the waiting begins. Tanks stand in quiet rooms. Names and dates are recorded. Families visit, if they wish, and rest a hand on cold steel. The present keeps going with its meals and weather reports and elections. Inside the tanks, there is only stillness. Set beside white holes and wormholes, cryonics feels close to the ground, and that closeness is part of its strange gravity. No exotic matter is needed, no negative energy, no new geometry. The materials are oxygen masks and tubing, pumps and nitrogen, checklists and legal documents. The risks, however, are no smaller for being practical. A facility must endure for generations without losing power or focus. Cultures change, economies turn, and promises can become burdens if they are not tended. The science may arrive slowly, or not at all. Ice and chemistry may prove kinder than expected, or harsher. Across all of this runs the moral question of what it means to pause a life in hope that others will unpause it later. What it means to wake with debts to people you have never known. Even with those weights, the attempt continues. The people who choose it are not breaking physics. They are asking time to pass without them and trusting that someone will have learned enough and cared enough to bring them back. Compared to chasing light or jumping a horizon, this path is both more fragile and more human. It leans not on spacetime's grand flex, but on the tenacity of communities, on medical skill, on memory. And yet, the essence aligns with the other visions. You go forward while feeling almost nothing. Others age, you do not. They speak of the seasons between, you do not remember them. You have crossed years in a single step, even if the step was taken by falling asleep into cold. The white hole remains a ghost from the equations. Perhaps nature never drew it on the sky. Perhaps it flickered and died in the first moments after the Big Bang, leaving no trace for telescopes. Perhaps it waits in a quiet corner, rare and brief, a fountain that has yet to be caught in a net of data. Until such a day, the concept remains a kind of compass point for thought. A black hole reversed, a door you cannot enter that throws you out, a partner for wormholes in the imagination's architecture. It frames a possibility without claiming it has happened. Cryonics, meanwhile, writes its own small entries in ledgers and newsletters. Cases are recorded, tanks are topped up, the nitrogen boils at its steady temperature, keeping the long pause intact. Staff walk the aisles and check instruments. Families receive updates. Somewhere, a file holds the name James Bedford, a mark from 1967 that has now outlived many of the people who read it when it was new. The facts sit side by side, a mathematical fountain that may never spray, and an industrial cold that definitely exists, chosen by a few to bridge a gap across time by doing nothing at all except enduring. Between these extremes runs the same thread that has guided every earlier thought. Time is a terrain, not only a ticking. Speed changes how your path climbs and falls along that terrain. Gravity deepens the valleys and slows the passage. Exotic geometries promise streams that carry you farther than walking would. Cold, applied with care, offers a way to wait while others travel. None of these erase the risks or the unknowns. All of them share the same quiet aim: to see a later sky. The mind can hold both moods at once. There is wonder in contemplating a tunnel that drops you into the year 4025. There is tenderness in considering a metal cylinder that remains an address for someone's hope. There is responsibility in both. A white hole would not negotiate. It would not slow down for fear or love. It would fire. Cryonics demands the slow work of institutions that do not forget. Both stretch our sense of future without violating the rules that already shape the present. The night keeps its calm while these ideas pass through. Black horizons exist. We have watched their signatures and mapped their edges. White holes belong, for now, to clean pages and careful whispers. Wormholes connect ideas more reliably than they connect places. Cryonics occupies warehouses and balances budgets and careful procedures. Above all of this, the same geometry rules. Space and time are one fabric. Clocks keep local truth. Speed and gravity change the rhythm. Equations carry possibilities that human hands must decide how or whether to reach. There is a small kindness in recognizing how all these paths, grand and humble, bend toward the same meaning. To travel into the future can be a sprint of light speed, a drift near a heavy mass, a ride on a shaped bubble, a pause in liquid nitrogen. The traveler always pays. The price can be fuel and engineering and risk, or patience and trust and the willingness to wake in a room full of strangers. None of this belongs to fantasy when described carefully. Each belongs to a different note in the chord we call time. The quiet lesson returns, softer than before. Whether the vehicle is a wormhole that never forms, or a storage tank that hums in a distant building, the rest of the world will go on. Trees will bud and drop their leaves. Distant galaxies will redden as the universe stretches. The same laws will be there when eyes open again or never open at all. The journey forward is always possible for others, measured in birthdays and seasons. The journey forward without you is always happening. The dream some people carry is to rejoin that flow after a long stillness and discover what the river has made downstream. No instruction is required to hold these thoughts. They settle like dust in a sunbeam, floating gently, drifting towards stillness. White holes, wormholes, cryonics, each offers a different shape to the same longing, the wish to touch another century while staying true to the world as it is. The scientific words remain close by, not as hard edges, but as anchors. General relativity, wormhole, gamma-ray burst as a hypothesis with no proof, liquid nitrogen at -196 degrees Celsius, a name from 1967, ice crystals and chemical damage, the vast distance between an elegant equation and a working device. In that distance lives the work of generations, and also the quiet, where a listener can rest. The future, whether reached by speed, by gravity, by geometry, or by the patience of cold, is not a single place. It is a widening field of possibilities, with room for caution and audacity, for equations and promises, for fountains that may never spray and tanks that never warm. To think about these things at night does not demand sleeplessness. It invites a gentler pace. The ideas become like stars, beyond a thin curtain, steady and far. Somewhere in that steadiness is the recognition that time, whatever door you choose, will keep moving for the world, and, with luck and craft and care, may someday carry you forward too. Rewinding a life feels like the kind of wish that belongs to fairy tales. Yet the quiet rooms of physics hold ideas that keep this wish from fading entirely. Moving forward through time already asks for patience and careful paths. Turning back sounds impossible at first breath. The mind still circles the question as the night deepens. Could a person ever step into yesterday without breaking the story that brought them here? Cinema gave that yearning a familiar face. A teenager climbs into a stainless steel car. The odometer climbs. The speedometer kisses 88 miles per hour. Lights flare, road lines blur, and 1,985 snaps into 1,955. The scene from Back to the Future is stitched into cultural memory because it makes a wild idea feel neighborly. A road, a number, a spark, a new year. On the other side, the car returns to the mall parking lot you recognize. The lampposts are in the same places. The world looks almost the same until it does not. The thrill is that time behaves like distance. Pick a destination and go. The dream underneath that scene is not foreign to scientists. General relativity was written to explain gravity and ended up reshaping time. The same equations that curve the paths of planets also admit tunnels and loops, strange corridors hidden inside the familiar landscape. Treat time as a coordinate woven with the three of space, the way a map stretches in two directions and a calendar stretches in one, and the thought arrives almost by itself. If space can be crossed by finding the right route, might time share that malleability under extreme conditions? Stories that keep a foot in reality often reach for different images than a sports car in a parking lot. Interstellar leaned into the same equations and asked what a black hole's weight would do to a small group of travelers. Earlier memories in that film had already shown how gravity leans on time. A water-covered world, circling close to a black hole, ran its hours so slowly that minutes there measured as decades aboard a waiting ship. Cooper and Brand knelt in shallow waves for what felt like an afternoon, while Romilly counted more than 20 years in a quiet module and learned to live with absence. No time machine flickered, no device clicked. Being near a massive body was enough to tilt the rate at which moments gathered. Later, a different kind of scene unfolded. Cooper chose to fall, giving the endurance its chance to live. Instead of ending in silence and pressure, he crossed into a place the film called the Tesseract, a higher dimensional room where every instant in his daughter's bedroom stood present at once. Linear sequence dissolved, past, present, and possible, traced across one another like transparent pages, stacked and slid. In that echoing lattice, he could reach the earlier room through patterns and pressure, sending messages he had already sent, becoming the ghost who had always been there. His actions did not fracture a timeline. They completed it. He did not make a new history. He illuminated the one that already knotted future and past into a single, consistent braid. This is the mood of an idea physicists call a closed, time-like curve. The phrase sounds cold until you sit with it. A time-like path is just the kind of path matter takes when it moves through space-time without breaking the rules. Closed means the path loops back to meet itself. Follow that loop, and you return to an earlier coordinate without tearing the fabric. The startling part is the self-consistency. Events along such a loop influence each other in a way that never creates contradiction. A message sent backward is the message that was always received. A hand that closes a latch is the hand that always closed it. The loop is strange, but the logic holds. Even with these softer paths in mind, people still ask for a doorway that moves a whole body into an earlier day. General relativity allows a candidate in the shape of a tunnel, the kind of tunnel sometimes nicknamed a wormhole. The picture is a familiar one from classrooms and documentaries. Imagine a wide sheet of paper that stands for space-time. 2 points on the sheet lie far apart. Drag your finger across the surface, and the distance is long. Fold the paper so the 2 points touch, and the distance collapses. Poke a hole between them, and a short passage appears. The formal name for this picture is an Einstein-Rosen bridge, a solution of Einstein's field equations that ties two regions together. Left alone in their pure mathematical form, such bridges close too quickly to walk. They collapse before use, like a hallway that pinches shut as soon as it is drawn. The fiction of holding one open asks for matter with a peculiar property. Ordinary mass bends space-time inward. A traversable tunnel would need a rim lined with something that bends it outward, a pressure that pushes against gravity's natural pinch. Physicists call that requirement negative energy density or exotic matter. The words sound like fantasy, yet quantum fields do produce small, temporary pockets where energy behaves in that flipped way. The Casimir effect, measured between metal plates placed close together, shows a delicate push that points in the right conceptual direction. Scaling that whisper into a structure large and stable enough for a traveler lies far beyond our present craft. Even so, the geometry itself offers a path for turning a wormhole into a clock that runs out of sync at its two ends. The idea is no more mysterious than the way time slows for a moving traveler or near a heavy mass. Assign one mouth of the tunnel a sedate life. Carry the other mouth on a long, fast journey near light speed. or rested for a while close to a massive object like a black hole. The moving or low-lying mouth experiences less time than the quiet mouth. Bring the two mouths into easy reach again, and they carry a difference. The way two identical watches do after one has taken a high-speed flight and the other has remained on a bedside table. Step into the older end, and you exit the younger end at a time that, for the outside world, counts as earlier. Reverse the walk, and you land in a later day. The tunnel has become an escalator, with two landings moving at different rates. Depending on which way you step, you rise into tomorrow or descend toward yesterday. There is a boundary on this trick that clears the fog around impossible hopes. A tunnel cannot take you to a date before it existed. The earliest reachable moment sits at the instant of the wormhole's creation. No route winds back to dinosaurs, unless the mouths were already there in their age. The timeline you could access begins when the device begins. The catch narrows fantasy into a principle that takes responsibility seriously. A civilization would need to build the tunnel, keep it open, and wait, and only the time between opening and walking would lie within reach. The difficulties do not end with energy that pushes instead of pulls. Stability matters. A mouth that jitters, or a passage that welcomes stray radiation too easily, could collapse in a blink. Tidal forces near massive bodies can shred anything not protected by impossible materials. Tiny disturbances add up in non-linear ways. Keep the bridge calm enough for a person to cross, and the world remains whole. Lose control for a breath, and the bridge pinches shut. The thought of being caught halfway is not one to dwell on before sleep, yet it belongs to the honest accounting of such a device. Paradoxes creep to the edge of the room as soon as a door to yesterday opens. People imagine sending warnings to their earlier selves, blocking meetings that led to their own birth, removing the causes of the messages they plan to send. General relativity does not slam the door on such loops by fiat. It allows solutions where closed time-like curves exist. The resolution that does not break causality is the same that kept Cooper's messages gentle. Self-consistency rules. Whatever a traveler does on the loop is the thing that always happened on that loop. The universe need not allow contradictions to persist. The set of events that can occur is narrowed to those that fit together without tearing logic. One of the careful voices on this topic belongs to Kip Thorne. Long before he put a black hole on a movie screen, he and collaborators wrote down conditions under which a traversable wormhole could, in principle, be turned into a time machine. The calculations did not violate known law. They asked for negative energy in the right places, for motion and placement that created the time offset between mouths, and for a control over geometry that exceeds anything we can engineer today. The result was not a blueprint you could hand to a workshop. It was a map of what would be needed, drawn with the best ink available, respectful of physics rather than contemptuous of it. The interplay between film and theory gently clarifies where imagination leans on fact. Back to the Future made time travel feel like a weekend errand, with a daring speed limit and a two-lane road. Interstellar sketched how gravity slows time and then put a human face on a consistent loop where a father became the source of signals he had always received. Neither film claims to be a lecture. One favors adventure. The other leans into the texture of real equations. Both remind us that a story can soften hard ideas enough to carry them in the pocket for a while. Questions about rewinding linger beyond screens. In the real world, a tunnel that carries you to yesterday requires materials that push against gravity, stabilization that tames quantum jitters, and control that can move a mouth without ripping its edges. The escalator analogy still helps. An escalator is safe when its steps are regular its rails smooth, its gears aligned. A wormhole time machine would need that level of regularity, written in space-time itself. Engineers know how many pieces must interlock for a simple machine to remain safe. The imagined tunnel asks for that care, multiplied until every photon, every fluctuation, and every tidal twitch is accounted for. There are gentler edges to this exploration that keep it from turning harsh. The universe does not forbid a visitor from touching their past in every telling. In a self-consistent picture, touching the past means becoming the person who always left that touch. A hand on a shoulder that you remember from childhood might be your own hand if the loop exists. The comfort is peculiar rather than warm, yet it preserves continuity. Nothing breaks. The loop closes without tearing. Numbers stay modest where they belong. The car in the old film still hits 88 miles per hour and explodes into light. The water planet near Gargantua still turns hours into decades. The wormhole remains a solution to Einstein's equations under the name Einstein-Rosen bridge. Negative energy density remains a requirement for keeping a traversable tunnel open. Closed time-like curve remains the technical phrase for a loop you can follow, without violating the local rules that govern matter. Changing the rhythm of time at a mouth, by carrying it near light speed or nestling it near a massive object, remains the method for putting the two ends out of sync. The rule about earliest reachable dates still holds. None of those details need more decoration to do their work. A different kind of stillness enters when these pieces settle together. Time can be shaped by speed and gravity. Geometry admits shortcuts under strict conditions. Consistency narrows what can happen. The most delicate doors require ingredients we have not learned to store. The overall picture is not cruel, it is careful. It says yes on paper, then lists the prices and the tools required in a hand steady enough to make an artist jealous. The human scale of all this remains worth noticing. People often reach for yesterday to mend regrets or to prolong a good minute that passed too quickly. Physics offers a quieter gift. It shows how the present is tied to a pattern that does not need to be undone to be understood. A film can give us the feeling of jumping backward on a road lined with neon. A theory can show us how a loop might allow a message to become the message that was always there. The two together slow the heartbeat of the question. Instead of demanding a miracle, the mind can watch how rules interlock and how stories wrap themselves around those rules. Imagination does not need to be retired. It can keep company with patience. A car door can close with a soft click in a driveway drenched in rain. Somewhere else, equations mark the conditions for tunnels and loops. Somewhere nearer, a person breathes and listens, and the wish to visit an earlier day quiets into a curiosity that does not scrape the nerves. The night is good for this. The clock whispers from the next room. The room you grew up in remains where it was, in memory, rather than in a tesseract. The version of you who needed a message received it, regardless of who sent it. The trail through these ideas returns to the same landmarks without tiring them. Back to the Future gave a feeling of ease to a difficult notion. Interstellar translated gravity's pull on time into the cost of an absence and into a lattice where consistency kept love from tearing physics apart. Closed time-like curves offered a formal way to speak about loops that do not break cause and effect. Wormholes provided a geometry for tunnels that can, in principle, become time machines when their mouths live different rates of time. Exotic matter stood as the necessary brace that holds the arch open. Stability and paradoxes remain the challenges that prevent a stroll into the past from being a weekend option. Somewhere between all of these, there is a way to rest inside the question rather than chase it down the hallway. The past that shaped you does not need rescue in order to be cherished. The future does not need to be rushed to arrive. The physics says that moving backward in time is not instantly forbidden by the laws that also draw orbits and keep a satellite's clock in step. It also says that the road to such a feat winds through materials and controls that stretch beyond the horizon of what we can build. That horizon can move. Horizons do. For now, the night remains a good laboratory. Ideas about tunnels and loops can be held lightly, without scraping the mind. The car at 88 miles per hour can remain a story, while the wormhole remains a solution in a textbook. The water planet can stay a symbol for the way gravity leans on time, while Romilly's gray hair stands in for the years that slip by elsewhere. The escalator that carries you to yesterday or tomorrow can stay a helpful picture for how two mouths of a tunnel might disagree about dates. The list of difficulties can remain a guide rather than a wall. A person lying awake may find that this is enough. The universe keeps admitting possibilities and then writing footnotes in careful ink. Some footnotes say not yet, some say yes, but only inside these boundaries. Some, like the Tesseract's consistent loop, say you have already been part of the story you long to enter. Through all of it, the rhythm of breath continues. Time's direction feels steady again, and the old wish softens into a kind thought for the people who will go on asking, who will keep folding paper in their minds and looking for a gentle way to cross from one point to another without tearing the sheet. Should a true wormhole ever be made and tended well, the first dates reachable will be the dates after its birth, and the first trips will be the kind that honor causality rather than mock it. Should closed time-like curves ever touch a human story, the consistency that saves cause and effect will feel less like a restriction and more like a promise that the world remains readable. The math already contains this music. The instruments to play it at full volume have not been tuned yet. In that space between principle and practice, sleep comes easily. Time holds its shape. The rules are kind enough to allow wonder and firm enough to prevent a heart from breaking on contradictions. Somewhere, a stainless steel car continues to spark along a movie road. Somewhere, a black hole continues to bow light into rings that look like fire. Somewhere nearer, a quiet reader keeps these notions company, and the past, for tonight, is close enough without being moved. Skipping backward is the harder dream. Yet, the mathematics that cradle gravity leave a narrow path where the dream can be pictured without tearing the rules. Hidden in Einstein's equations is a family of spacetimes that do not march from past to future along a straight avenue. In certain shapes, the avenue bends into a loop. Physicists call such a path a closed time-like curve, or CTC, and the phrase means exactly what it says: a lawful route for matter and clocks that closes on itself in time. Picture walking forward at an easy pace, second after second, with a wristwatch that never misbehaves. The road curves so gently that no step feels strange, yet the loop eventually carries you to a moment that, on any ordinary map, lies in your own earlier day. No switch is flipped, no forbidden speed is reached. The traveler stays within the speed limits of relativity and still returns to a point that once sat behind them on the calendar. Time, in such a space-time, is not a straight corridor. It has a curvature of its own. This possibility first took a precise form in the 1940 seconds, when Kurt Gödel, already famous for theorems about logic and completeness, wrote down a model of the universe that solved Einstein's equations. In Gödel's cosmos, large-scale rotation twists space-time so thoroughly that CTCs thread the geometry. The equations do not protest. They quietly admit a world where a patient traveler could follow a time-like path and eventually arrive at an earlier coordinate. It was an idealized model rather than a portrait of the sky above us, yet it proved that general relativity tolerates time loops in principle. Other solutions carry the same flavor. Near-rotating black holes, known as Kerr black holes, space-time is dragged around by the spin, a phenomenon called frame dragging. Deep inside certain regions of those solutions, the spiraling becomes so intense that time-like paths can close. This is not a tour suggestion. No probe has mapped a safe passage there, and the violent environment would destroy ordinary matter long before any loop could be traced. Still, the mathematics continues to allow the shape. Curvature can curl time. At smaller scales, the quantum world adds whispers that sound like riddles about time's order. Quantum field theory, which weaves special relativity together with quantum mechanics, uses compact sketches called Feynman diagrams to track interactions. In that bookkeeping, a line drawn as a particle moving backward through time can be reinterpreted as an antiparticle moving forward. The two readings are equivalent. A positron, the antimatter partner of the electron, can be described as an electron with its temporal direction flipped in the diagrammatic language. It is not a ticket for people to reverse their lives, but it shows how time reversal appears naturally in the equations that govern particles. Quantum tunneling adds another twist, one we can measure in the lab. Particles sometimes arrive on the far side of an energy barrier without possessing the classical energy to climb it. Waves spread. Probabilities allow short, sharp exceptions. Detections happen where rigid rules would forbid them. Interpreted carelessly, this looks like rule breaking. Interpreted with care, it is a feature of quantum amplitudes spreading in time as well as space. The particle has not traveled along a classical shortcut through yesterday, yet the effect feels like a small cheat against ordinary expectations about cause and arrival. Scaling any of this up meets a wall. The delicacy that allows a particle to borrow energy for a heartbeat or slip through a barrier collapses in the presence of heat and noise. Larger systems decohere. The soft quantum tricks wash out as soon as many degrees of freedom are involved. At human scales, time's arrow reasserts itself with the regularity of tide and moon. Even so, the picture of loops invites a different kind of worry, the kind that lives in paradoxes. As soon as yesterday becomes accessible, contradictions peek from every corner. The grandfather paradox steps forward first, because it is easy to tell. A traveler arrives in an earlier era, tangles with a chance meeting, and prevents a relationship that would have led to the traveler's birth. The parent is never born. The traveler is never born. The trip cannot happen. The meeting is no longer prevented. The loop sharpens until reasoning breaks. One family of answers tries to preserve time travel without snapping causality. In the many worlds interpretation of quantum mechanics, alternative outcomes branch rather than cancel. A traveler who interferes with an earlier courtship does not erase the branch that produced them. A new branch is created that proceeds without the traveler's eventual birth, while the original line remains intact. The past from which the traveler launched stays unmodified. A copy now exists in which the traveler never appears. It is neat and cold. The contradiction is gone. The hope of repairing a wound in one's own history is gone with it. Another puzzle is stranger because no contradiction appears on the surface. The bootstrap paradox asks where creation begins when an object or a piece of information loops without a source. Imagine someone arrives in the past with a book of Beethoven's symphonies and gifts it to the young composer. He copies it. The world learns to love the music, and years later, the time traveler uses the famous scores as the source for the book they carry back. The music exists along the loop. No first act of composition can be found. Cause and effect hold hands so tightly that the origin is nowhere and everywhere. Some physicists accept that such self-contained loops could exist if CTCs exist. Others feel the absence of a true beginning as a sign that nature would forbid such patterns in practice. A cousin to both is the predestination paradox. Efforts to prevent a known outcome become the very steps that ensure it. A person learns of a disaster and dedicates their life to stopping it. Their intervention sets in motion the chain that causes it. Stories return to this shape because it feels familiar in the gut. Attempts to outmaneuver fate often run along the same grooves that fate follows. Films have used these shapes to make the mathematics human. In 12 Monkeys, the hero aims to halt a plague and discovers that his actions help script the doom he wanted to erase. In The Terminator, resistance to a machine-ruled future ends up seeding that future. In Harry Potter and the Prisoner of Azkaban, a young wizard sees a saving spell from afar and later learns that he was the one who cast it. The loop is tidy and causality stays intact. Returning to the physics after those narrative mirrors, the lesson remains steady. General relativity permits time loops in certain, exact solutions. That permission is not a promise. Creating or navigating a CTC would require an environment whose curvature is set just so and whose violence does not tear travelers apart. Even wormholes, which many people imagine as natural time machines, would need exotic matter with negative energy density to hold them open. Closed time-like curves, by contrast, can arise from the geometry itself without a separate tunnel, yet their habitats are likely to be regions where no living thing can endure. The quantum hints are weaker bridges than they seem on first hearing. A positron behaving like an electron with its arrow reversed is a formal symmetry in the mathematics. Quantum tunneling is a probabilistic spread that produces arrivals in classically forbidden places. Both are real. Neither is a practical path to sail a person back to an earlier week. The world changes character as it grows in size. Local reversals in equations do not translate into global escapades in time. Behind the paradoxes and the exact solutions is a quiet force that gives direction to experience. Thermodynamics writes an arrow by counting possibilities. Ordered arrangements are rare, disordered ones are common. Isolated systems relax from special states to typical ones. Memory records traces left by earlier events and does not record traces from events that have not yet scattered their footprints. Even if small parts of the universe can be coaxed into curls, large assemblies of matter and light drift along entropy's slope. The present is a moving edge of that relaxation, with information flowing from past to present more easily than the reverse. Physicists who want to keep causality unbroken inside time travel scenarios often reach for consistency conditions. The Novikov self-consistency principle is one such tool. It requires that any events occurring on a CTC be globally consistent, which rules out actions that would generate contradiction. In that spirit, the message a traveler sends into their own past is always the message that was received. The latch that must be closed is always closed by the hand that later remembers closing it. The loop becomes a circle where every point agrees with every other point. Freedom narrows, yet logic survives. Meanwhile, the many worlds picture leaves logic intact by letting contradictory outcomes inhabit separate branches. It has a different cost. Personal history remains beyond repair. Interventions spawn new histories, rather than retroactively healing old hurts. Even the bootstrap example can be absorbed. The score that loops along the curve does not violate any local law, and energy and information are conserved around the loop. What is lost is a satisfying origin story. The universe becomes comfortable with circles. A softer conclusion follows from this entire tangle. Backward travel is not ruled out by the letter of relativity. It is constrained by geometry, stability, energy, and consistency. The solutions that allow it live in extreme conditions. The paradoxes that stalk it can be calmed either by narrowing what events are allowed or by multiplying branches so that incompatible outcomes do not collide. None of these moves provide an easy path to machinery. Each provides a way for the laws to tolerate the idea without breaking. This distinction matters. Physics can be permissive in principle and restrictive in practice. A CTC is a permitted curve on paper, yet the habitats where such curves arise may be unreachable or fatal. A wormhole stabilized for travel is not forbidden by the equations, yet it demands negative energy arranged with precision we cannot approach. Quantum tricks are spectacular and real, yet they fold under the weight of macroscopic complexity. Paradoxes look lethal until self-consistency and branching interpretations soften them. The softening comes with a philosophical price. Under night sounds and slowed breathing, this can feel strangely comforting. The universe is not brittle. It will allow thought experiments to wander far without snapping the main beams that hold causality together. A teenager in a sports car can show how the heart longs for a simple dial to twist. A rotating black hole in an exact solution can show how space and time might curl together until a path meets itself. A particle and its antiparticle can show how different pictures can describe the same dance. A tunneling experiment can show how arrival times bend intuition without wrecking cause and effect. The feeling that remains is not futility. It is a clear-eyed appreciation that the past we carry is resilient. Even in stories where loops exist, the loops tend to preserve the pattern rather than demolish it. Even in interpretations where branches split, the original branch still holds what it held. The will to change yesterday becomes a gentler interest in understanding how yesterday is sewn to today. The mind relaxes around that insight, the way a muscle relaxes in warm water. None of this requires abandoning wonder. A closed time-like curve is a profound idea. Gödel's universe remains a reminder that different global structures lead to different temporal possibilities. Kerr spacetimes display how rotation drags the fabric around, and how intense curvature might encourage loops in regions far from comfort. Quantum field theory balances on symmetries that allow you to swap time directions in a diagram and still make correct predictions. Tunneling continues to slide particles through barriers and continues to power technologies we depend on. Paradoxes keep us honest by exposing where desires collide with rules. Time travel to the past, put into this quiet frame, is not a toy that the universe has left lying around. It is a possibility that the equations can draw, a possibility fenced in by conditions that are hard to meet and by principles that keep stories from collapsing into nonsense. The universe seems to prefer consistency over drama. That preference does not forbid loops outright. It just makes them exacting, constrained, and possibly confined to places and scales that refuse to host a human life. The path forward from here is familiar. Better observations of extreme environments, sharper tests of gravity in strong fields, deeper work on quantum theories in curved spacetime, clearer experiments on coherence and decoherence at mesoscopic scales. None of those guarantee a time machine. All of them make our language about time and causality more precise and our imagination better grounded. For a late hour, that is plenty. A single rule can be cradled without being crushed. In the best descriptions we have, time is woven with space. Curvature can make loops. Quantum laws allow odd symmetries. Thermodynamics leans the world toward a direction we feel as an arrow. Paradoxes are guardrails, not proofs of chaos. Even the most cinematic wishes fit within a universe that values coherence. The sidewalk may hold a footprint now and then, and the cement may never be reshaped once it sets. A traveler can still lean down and trace the outline with a fingertip, grateful for the pattern that brought them here, aware that the road ahead is long and alive, and content to walk it in the order the world provides. Gathering every wild idea into one patient thread changes the mood of the question. Instead of searching for a single magic key, the mind begins to picture a careful weave, each strand contributing a small, necessary strength. Bending time would not be a drive down a road, it would be the shaping of the road itself, coaxing the fabric of space-time to fold and tilt in our favor. That kind of work would demand a heart far stronger than anything we now keep in laboratories. Motion through time is not paid for with gasoline or sunlight. It asks for energy that can grip geometry and tug. Physicists looked across the sky for engines that already twist time, and one object kept returning to the page. A black hole is powerful enough to bend the paths of light and shake clocks, and the rotating kind, a Kerr black hole named for Roy Kerr's 1963 solution, does something stranger than simply sit as a dark weight. Spin couples to space-time. The hole drags the nearby fabric around with it in a phenomenon called frame dragging. The region just outside the horizon, the ergosphere, is swept by that rotation so strongly that standing still with respect to distant stars becomes impossible. The image is less a stationary pit and more a gravity tornado, a whirl that takes everything in its grip. Paths near that swirl do not behave like paths in calm space. Under the most extreme conditions, the direction of time that feels fixed to us can tilt in ways that, on paper, allow loops. That picture is enticing and terrifying at once. The same geometry that hints at closed time-like curves sits in a neighborhood that punishes matter. The fields, the tidal forces, the radiation from the accretion disk all climb to levels that no present material can endure. Approaching the event horizon would be like bringing a paper kite into a thunderhead and hoping to bottle lightning from the inside. Engineers have imagined a calmer compromise, a station placed at a respectful distance from a spinning black hole, far enough to survive, near enough to feel the spin. Energy streams in. The accretion flow could be tapped by colossal magnetic structures, the chaos of plasma shaped into currents that feed the machinery. The idea is not a blueprint, only a picture of how raw power might be harvested from a natural dynamo. Raw power would still be only the beginning. Geometry needs to be sculpted, not merely shouted at. The mind reaches for a gentler analogy to hold the next step. Stir a bowl of thick honey and, for a while, the surface simply circles. Stir harder and the center draws down, spirals and dimples forming where the flow grows fastest. A space-time ring would attempt that with gravity itself, pouring rotational energy into a shaped mass so that the surrounding geometry begins to twist in closed patterns. This is the spirit behind the Tipler cylinder. Frank Tipler, building on work by Willem van Stockum, described in 1974 an infinitely long cylinder of ultra-dense matter spinning at nearly light speed. Around such an object, the equations of general relativity admit closed time-like curves. A traveler could, in principle, follow the swirl and arrive in an earlier time coordinate. Infinity is a luxury the universe does not sell. An endless cylinder cannot be built, and a finite one does not simply inherit the same loops. A truncated machine would need exquisite tuning and likely assistance from something beyond ordinary matter to generate usable curves without collapse. Our imagined device shifts the cylinder into a ring, a titanic torus bright with waste heat and encircled by the fields required to keep it intact. The ring would carry mass and rotation at the edge of what any future material could bear, a luminous hula hoop of starlight speeds. The scaffolding would require matter stronger than any alloy we know, perhaps exotic states yet to be created, perhaps even the tensile fantasy of cosmic strings in some far theory, filaments thinner than atoms and heavier than mountains. None of these are in hand, yet the ring offers a shape for the mind to work on, a place to pour energy and see whether spacetime will respond with the loops we seek. Assume the ring holds. The geometry nearby begins to twist. Paths that once ran straight in time bend into slow curls. Those curls are not a tunnel, and they are not a doorway either. They are a kind of eddy in the river, a place where time-like curves could close if the swirl is strong and clean. Getting a person into the eddy and back out again safely would demand a passage more controlled than a whirl alone can offer. The search turns to wormholes, the shortcuts that sit naturally in Einstein's field equations under the name Einstein-Rosen bridges. In their bare mathematical form, they close too quickly to be crossed. Stabilization requires a pressure against gravity's instinct to pinch, something that behaves as negative energy density, so that the throat stays open. Exotic matter with negative energy sounds like a story, until you recall that quantum fields can briefly arrange themselves in ways that, over small regions, act with the required sign. The Casimir effect is the classic hint. Place two metal plates extremely close together in a vacuum and measure the tiny force that draws them inward. The space between the plates hosts fewer quantum modes than the space outside. The difference creates a pressure that looks, in the accounting, like negative energy in the gap. This is not the exotic matter we would need in bulk, not a fuel to pour into a tank, but it proves that the universe's rulebook includes pages where negative energy is allowed in principle. A stabilized wormhole would ask for enormous amounts, arranged with care so that the throat inflates and holds while a traveler crosses. Power, shaper, passage, each part leaning on the others. One more piece remains, quiet and crucial. Navigation in time is navigation in space as well, because locations do not sit in a cosmic grid that waits for our return. Earth turns on its axis and orbits the Sunday. The sun rounds the galaxy. The galaxy drifts through a local flow. A careless step backward by minutes without a map would place a traveler in empty, dark, meters or miles from where the planet now stands. A careful step needs beacons that do not blur when clocks disagree. The best candidate for such anchors may live in the correlations that quantum mechanics allows. Entangled particles share a link that remains even when they are separated by great distances, a kind of matched randomness that no signal rides and no classical common cause explains. Experiments by Anton Zeilinger and colleagues on quantum teleportation showed that entanglement can carry the exact structure of a quantum state from one place to another, provided classical information completes the task. Jianwei Pan's work with satellites extended entanglement across hundreds and then thousands of kilometers, proving that the delicacy of the link can survive free space and orbital dynamics. A future web of entangled pairs, distributed between reference stations and synchronized clocks, could serve as a map that is not inscribed only on positions, but also on times. Each node would be a lighthouse whose light cannot be forged, a marker that helps a traveler lock onto a space-time coordinate rather than a mere location. The picture now has 4 elements that speak to each other. A rotating black hole offers a natural reservoir of energy and a way to twist geometry strongly, though any practical approach would remain far outside the lethal boundaries near the horizon. A man-made ring concentrates rotation where we want it, turning harvested energy into a controlled twist that encourages closed time-like curves in a survivable neighborhood. A wormhole stabilized by negative energy provides a tunnel through the twist, a passage that does not shear or collapse before the crossing is done. An entanglement-based navigation grid keeps the traveler tied to the correct when as well as the correct where, so that the Earth that was sought is the Earth that appears outside the hatch. The order matters, and so does the humility with which each step is held. At every stage, the obstacles are immense. Materials strong enough to hold a relativistic ring together are beyond our shelves. Exotic matter with usable negative energy has not been bottled. Stabilizing a wormhole demands control over quantum effects in curved spacetime that no current theory or instrument can claim. Energy extraction from a Kerr black hole's environment would rely on magnetic structures so large and precise that even the analogy of turbines in a storm understates the task. Navigation by entanglement would require networks that span planets and perhaps stars, with clocks so disciplined that drift becomes negligible over years. None of this negates the structure of the idea. It sets the scale of the ambition. There is a quieter reason to keep the weave intact, even while acknowledging the chasms. Each piece addresses a different failure mode. The ring replaces chaos with a designed region of twist, so that the formation of loops does not depend solely on a hostile natural environment. The wormhole replaces a long swim in turbulent curvature with a short, protected transit. The negative energy solves the instant collapse that otherwise makes bridges useless. The entanglement grid replaces blind jumps with locatable arrivals. Paradoxes still haunt the edges, and any working device would have to satisfy consistency conditions so that causality does not shred. That demand could be built into the navigation itself, restricting allowable departures and arrivals to pairs that do not provoke contradiction. None of these statements claims a schedule. They offer a map of how the theories we already trust could be placed side by side without insulting one another. General relativity provides the geometry and the rotating solutions that twist it. Quantum field theory provides the possibility of negative energies and the entanglement that could help with anchoring. Astrophysics provides the engines that already run in the sky and might be tapped by future machines that know where to stand. Engineering, imagined at a scale that dwarfs the present, provides the ring that holds together and the fields that shape plasma into power rather than danger. The mind can walk around the machine slowly and listen to it hum. Far away, a black hole spins, its ergosphere a bright collar where matter heats and radiates. A station keeps a safe orbit, harvesting a portion of that fury with magnetic funnels that direct charged streams into generators. The current feeds a ring that glows along its edge, the surface laced with structures that carry stress away and launch it into surrounding fields. Nearby instruments monitor the twist in space-time, not in poetry but in numbers, watching for signatures that curves in time are beginning to form. A stabilized throat is held open by negative energy arranged in a shell, the throat expanding to a size that does not tear a body. In the distance, beacons that never blur check in, their entangled partners confirming that clocks are still hand in hand across the grid. A course is plotted, a window opens, the step is made. No one now can build this. That is not the point of holding it in mind. The point is to see that the wildest elements of the dream are not loose threads. They can be tied to specific places where the laws of physics already contain the required behaviors. Kerr black holes frame, drag, and offer energy. Tipler's cylinder shows how rotation could, in principle, generate loops. Wormholes appear in the equations, waiting to be stabilized by negative energy. The Casimir effect whispers that negative energy is not a forbidden word. Entanglement, tested on mountaintops and through satellites, hints at networks that might one day serve as lighthouses for travelers who must arrive not only somewhere, but somewhen. The night is a good time to hold such a machine gently. Nothing in this story demands belief beyond what has been given by observation and well-tested theory. Only extensions, arrangements, and scales that climb beyond our reach. The past remains safe from our impatience. The future remains open to our craft. And the present remains the place where we rest, while imagining bridges that may never be built and rings that may never turn. Even so, the act of picturing them refines the questions we ask, clarifies the limits we accept, and reminds us that the fabric we move through is not fixed stone. It is a pliant field that can, under the heaviest of hands, swirl and fold. On another night, the same thoughts might arrive with different images. Tonight they arrive as a weave, a black engine that spins without tiring, a luminous ring that holds like a vow, a throat that stays open because the vacuum itself agrees to shape its energy the other way, a grid of whispering particles that keep their promises over oceans of space. The human part of the story is simple. We do not have such tools. We do have the patience to imagine them clearly and the discipline to keep our imagining inside the laws that have proved themselves. That is enough to invite calm. The river of time continues to move under the windowsill. The clock is steady. Somewhere in a diagram, a loop closes neatly. Somewhere in a lab, two photons answer one another in the same instant. Somewhere in a galaxy's heart, space-time is being dragged around like a slow storm. Everything that would be needed for the grandest machine remains separate. Everything required for wonder is already here. Building a time machine, even as a bedtime thought experiment, feels like working a puzzle made from pieces borrowed from different games. One piece wants the pull of a spinning black hole. Another asks for a ring so strong and swift that ordinary matter would tear. Another whispers about exotic energy that props a wormhole open against gravity's squeeze. Another requires a navigation grid written in entangled light. And over everything hangs the hope that the universe's own rules will allow the whole contraption to operate without swatting it flat. Each ingredient, by itself, already sits at the edge of wonder. Asking them to cooperate is like asking a miracle to wear a second halo. The quiet consolation is that the best theories do not close the door. They leave it cracked, just enough for curiosity to keep watching. General relativity tolerates loops and bridges under extreme conditions. Quantum fields permit rare arrangements where negative energy shows its face. Entanglement has crossed mountaintops and low Earth orbit and still held steady. None of this adds up to a machine. It does add up to a sentence that ends not with never, but with not yet. Imagine what a civilization with patient centuries might learn to do. Stars could become engines rather than distant hearths. Rotation and curvature could be shaped the way we shape wind with turbines. Quantum weirdness might become as familiar as magnetism is now, a tool rather than a riddle. From such a vantage, the ring that strains at light speed, the wormhole that needs careful bracing, the beacons that tie place to moment, all could be parts in a catalog, not legends, in a story. There is also the sober side. Perhaps the cost in energy and risk grows faster than ambition ever can. A ring that fails might fail catastrophically. A throat that collapses could disgorge radiation no shield can tame. A navigation error would not be a wrong turn on a quiet road. It would be a step into empty dark. A sensible species might try once and decide that wisdom means archiving the design and walking away. Another possibility sits with equal weight. Success could carry travelers off the page we are reading. A journey that lands in a branch of history we cannot access would be invisible by definition. From our vantage, the room stays empty and silent, even if, elsewhere, the door opened and someone walked through. None of this makes the chase a waste. Reaching toward time sharpens everything we already do well. Better clocks arise, because keeping faith with seconds matters. Stronger materials and cleaner fields are born, because rings and magnets and plasma demand them. Gravity is measured closer to its sources, because extreme curvature refuses to be guessed at from afar. Quantum networks are built and tested, because even a daydream about anchoring a destination needs lighthouses that never blink. The questions grow braver, and the answers, even when they say not here and not now, make the world more legible. Science has always mixed humility with reach. Rockets came before starships, lenses before observatories in space, ink on paper before radio maps of a black hole's shadow. Every step that looked impossible softened under years of human hands. Time travel sits farther out on that path than most dreams. It may stay there, a bright object on the horizon that guides the direction without ever being reached. That is still a service. A horizon tells you which way the land leans. There is a gentler lesson folded inside the engineering. The universe appears to love coherence. It allows fierce ideas and then surrounds them with conditions that keep stories from breaking. Loops in time, if they exist at all for beings like us, will likely be self-consistent, the kind that preserve rather than overturn what has already settled. Branching histories, if that picture is right, will protect the thread you lived even as new threads unfurl. A machine, should it ever hum to life, would operate inside those guardrails. The romance would remain, and so would the responsibility. When someone says time travel is impossible, a small, patient smile is fair. Impossible today often means we do not yet know how to pay the bill. The universe is wide and particular, fond of surprises that still respect the rules. History is crowded with moments when a culture learned to do what its grandparents could not imagine. Fire tamed stone, glass gathered light, equations steered metal beyond air. On a long enough timeline, yesterday's magic often becomes a manual. For tonight, the clock in the next room keeps steady company. The river of time moves as it always has, carrying memory downstream and possibility ahead. Somewhere in that river, equations continue to hold open a narrow channel where a device might one day drift. Somewhere nearer, the value of the search is already here. Every attempt to understand time makes the present more meaningful. Every careful failure teaches the limits of matter and mind. Every new instrument that listens for subtle bends in space-time or whispers between paired photons gives us a clearer map of the world we actually inhabit. So the story can close softly. A machine that folds minutes like paper may never roll out of a hangar. The attempt to imagine it has already given gifts. We know our clocks and our skies better. We know where the laws are generous and where they are stern. We know that curiosity can stay awake without turning frantic. If a distant century boards a vessel and sets a course for yesterday, They will do it with the same tools that have always taken us forward: patience, honesty, and care. Until then, we can rest. The universe keeps good time, and the questions that matter most will be waiting in the morning, unhurried, ready to be held again.